Is the universe really 26.7 billion years old instead of 13.8 billion years? This fantastic recalculation is partly due to the discovery of a Milky Way doppelganger that should not actually exist. The James Webb Telescope discovered so many highly developed galaxies in the early universe shortly after the old Big Bang that it's already almost certain our old theory was wrong. Does the recalculation of the age of our universe now really provide the answers we are looking for, or does this new theory raise even more questions that cannot be answered? The James Webb Space Telescope has discovered over 1,000 galaxies in the early universe that are similar to our Milky Way. These galaxies were observed in a time span of a few 100 million to 1 billion years after the Big Bang, contradicting previous assumptions that disk galaxies were rare or impossible in this era. The disk shape is supposedly the result of frequent galactic collisions. However, at a time when the universe and all the galaxies in it were still in their infancy, there can hardly have been many such collisions. In fact, the number of galaxies discovered by James Webb is too high. These galaxies certainly show signs of young galaxies, but overall, they are too developed and too highly organized if we apply our old standards and ideas of galaxy development. Applying these standards to these galaxies suggests that their formation would have been before the Big Bang 13.8 billion years ago. Researchers found 3,956 newly discovered galaxies in a photo that actually shows only a few misshapen star clusters at the beginning of time. Of these, 1,672 have now been classified as disk galaxies, thanks to the fantastic spectrometer analyses of the Webb telescope. This shows that disk structures were present in about half of the galaxies, far more frequently than previously thought. These galaxies existed when the universe was only a few 100 million years old. These discoveries require a reassessment of previous models of galaxy formation and evolution, which assumed that large and highly structured galaxies could only have been formed by collisions of dwarf galaxies. The researchers, who published their latest study results in the Astrophysical Journal, emphasize that these findings underline the power and scientific value of the new telescope and that we urgently need to revise our old theories. The new data on our understanding of galactic evolution and the abundance and stability of disk galaxies in the early universe call into question the Big Bang and other fundamental pillars of our astrophysics. In this context, the galaxy Sears 2112 is particularly emphasized. Sears stands for Cosmic Evolution Early Release Science Survey, and this galaxy was discovered at a time when the universe was just 1.5 billion years old. Sears 2112 shows remarkable similarities with our own Milky Way, which surprised researchers. The Milky Way took billions of years to develop into a disk galaxy with distinct spiral arms. Finding a double at such an early stage of the universe is unexpected. Previous theories assumed that disk galaxies like the Milky Way formed much later in cosmic history. The discovery of Sears 2112 challenges these assumptions and suggests that such galactic structures could have evolved earlier and possibly faster than previously thought. One of the strangest features of Sears 2112 is its relatively undisturbed structure at such an early cosmic age. Galaxies would still be expected to be misshapen and chaotic, yet Sears 2112 shows a surprisingly stable and well-defined disk structure. This raises questions about how this galaxy got its shape and what previously unknown conditions in the early universe made this possible. If we apply our old standards of galaxy evolution to Sears 2112, this galaxy would also have formed at a time when the universe did not officially exist, at least not according to our old science. These discoveries speak a language that has led some scientists to recalculate the age of our universe, and the results are astonishing. Is the Big Bang the truth or a lie? There has long been at least as much evidence against the Big Bang as for it. The only problem was that certain theories had a long history of being established and accepted, almost regarded as incontrovertible truths. As a result, some scientists overlooked the fact that there were other alternative and equally good explanations for many space phenomena. Even when the discrepancies and gaps in the theories and explanatory models became ever greater, the researchers did not react. They stubbornly stuck to what had been considered true since the 1920s. After the Big Bang, which took place around 13.8 billion years ago, the universe was initially an extremely hot and dense mixture of protons, electrons, and other elementary particles. For the first 380,000 years, the universe was too hot for atoms to exist. During this period, the universe consisted mainly of ionized plasma. As the universe continued to expand, it cooled down. At a temperature of about 2730 degrees Celsius, protons and electrons were able to recombine for the first time to form neutral hydrogen atoms, an event known as recombination. The cosmic microwave background, which we use today as a kind of map of the universe, is said to have been created during this phase and is also used to reconstruct the early history of the universe. In the 100 million years following the recombination event, the Dark Ages prevailed, with no stars or galaxies. The universe was dark and consisted mainly of neutral hydrogen and helium. However, density fluctuations in the universe led to the formation of large gas clouds, which became more dense due to gravity. Imprints of these density fluctuations can still be detected today in microwave radiation from tiny variations in the temperature of the radiation. For example, we have also read off all the clues about large-scale structures in the universe. The first stars, known as population 3 stars, were formed about 100 million years after the Big Bang. These stars were massive, with masses ranging from tens to thousands of solar masses, and they were extremely bright. After a short lifetime, they ended in supernova explosions that released new elements and gases into the universe. These heavy elements were the nuclei for the formation of new stars and galaxies. The first galaxies were probably formed during this time. By the contraction and merging of smaller gas clouds and protogalactic clumps, these early galaxies are thought to have been chaotic and small compared to today's galaxies. Over time, ongoing star formation and galactic mergers led to ever larger and more structured galaxies. Now, thanks to the JWST, we can see galaxies that have been proven to exist since 250 million years after the Big Bang, and these galaxies are so developed and structured that they appear as if they have already undergone several billion years of development. This points us in 3 new directions: either the Big Bang never happened and the universe is eternal, or the Big Bang took place at an earlier point in time, making the universe much older than we previously thought, or stars and galaxies evolved in a turbo process. Rendra Gupta, a scientist at the University of Ottawa in Canada, proves the universe is 26.7 billion years old. Did you think it would be so easy to come up with a new age for the universe? Gupta has been researching alternative models of cosmic expansion and the nature of dark matter and dark energy for some time. All 3 factors are certain weaknesses in our old theories. Neither the uniform expansion nor dark matter or dark energy have ever been scientifically proven, so it's not certain that they really exist. After Webb's first images and the shocking discoveries, Gupta felt strengthened in some of his thoughts. He was one of the first scientists to dare to reassess the age of the universe. Gupta's new approach differs from traditional methods based on the cosmic background radiation and the Hubble constant. The Hubble constant is a measure of the rate of expansion of the universe, and its accurate determination has been crucial to previous calculations of the age of the universe. However, different measurement methods have provided different values for the Hubble constant, leading to the so-called Hubble tension. In plain language, this means that the expansion of the universe is not the same everywhere, which it should be according to the theory of the Big Bang and the idea that space has been drifting apart ever since. To solve this problem, Gupta has developed a model that introduces alternative cosmological parameters and presents the effect of dark energy and dark matter in a completely new way. With these new parameters, it could be that the universe is expanding much more slowly or non-linearly. A slower expansion model would mean that the universe is much older to reach the observed degree of expansion. An irregularly expanding universe could indicate previously unknown structures and forces, or that there may have been multiple starting points. A central element in Gupta's theory is the modification of the general theory of relativity. His hypothesis proposes that the physical behavior of dark energy has changed over time, which could explain the change in expansion. However, this would also mean that dark energy mutates and is a more dynamic quantity than we have previously assumed. In a first recalculation of the universe, Gupta arrived at an age of 26.7 billion years. He also presented another alternative calculation according to which even 42 billion years would be conceivable. In another paper, the researcher took into account Fritz Zwicky's theory of tired light, developed in the 1920s but later received little scientific attention. According to this theory, the wavelength of light changes as it travels through the cosmos. If this is true, all our previous calculations on the age of the universe and the distances within space would very probably be wrong. A universe that is almost twice as old as previously thought would easily explain the existence of galaxies like Sears 2112 and all the other highly evolved galaxies in Webb's images. Gupta's model could also explain why some observations of distant galaxies and quasars are difficult to reconcile with the current cosmological model. So far, however, the scientific community has found it difficult to accept Gupta's recalculation. Most conservative branches of astrophysics currently still insist on the Big Bang, which took place 13.8 billion years ago, and prefer explanations that assume stars and galaxies in the universe formed quite differently and much faster. Subscribe to the channel now, there are always new exciting videos coming.